Hello and welcome. Myself Ashish Sharma along with Fungsubar Basumatary is going to present our project of BTech 7th semester from CIT Koprasar Instrumentation branch. So the title of our project is Solar Power Inverter, guided by Assistant Professor Sir Dipendeka and HOD in charge Sir Dipankar Sudhakar. So in our project we have used a solar tracker circuit so that it absorbs, it takes maximum amount of sunlight from the sun. When the sun moves from east to west during a day, correspondingly this panel will track the sunlight from east to west. Now let me show you. When the sunlight falls maximum on LDR1, this is LDR1 and that is LDR2. So when sunlight falls on LDR1, the panel will track the light and it will move towards left. So let me show you. You can see as the light falls on LDR1, the panel moves towards me. Similarly, when the light will fall on LDR2, it will move towards that right side. You see? So this is how a solar tracker circuit tracks the sunlight. We can also move this panel on vertical direction. In the vertical direction, what happens? We have put a motor here to move the panel in left and right in vertical direction. So let me show you. When I put the light LDR4, it moves in one direction. Similarly, when I put the light on LDR4, it moves to the other direction. Okay. So here we have used LM339 as comparator circuit and L293 the motor driver circuit. So what happens is that when light falls on LDR1, its resistance decreases, due to which the output pin of motor driver circuit, pin number 3 and 6, it goes high, and due to which the motor moves in clockwise direction. Next, when LDR2 receives more light, then its resistance decreases, due to which the pin number 2 of comparator, it goes high, and the motor, suppose previously it was moving on clockwise direction, next it moves on anti-clockwise direction. Similarly, the LDR 3 and 4, it works on the same principle. Next, what we'll do is that we'll take the output voltage from the solar panel, this, to the inverter circuit. One will take to the inverter circuit, and next we'll take to the charger circuit. Through charger circuit, we'll take to the battery. In absence of sufficient power from solar panel, the battery will back up the whole system. So let me show you how the inverter works.
The inverter circuit. Then this is the battery charging circuit. This is the battery. Its rating is 7.2 ampere hour and 12 volt. This is the transformer which we have used. Its rating is 24 volt and output 24 volt output and 5 ampere. Then this is the load which we have taken as a bulb. Its rating is 10 watt 240 volt. So we have connected
it comes first to the inverter circuit from the solar panel. So in place of solar panel, here we have used the SMPS. And next the connection comes to the charger circuit. This is the positive side and this is the negative side. And from charger circuit we have connected the battery. This is the positive terminal of the battery. Yes, this is the positive terminal, and this is the negative terminal. Next, the battery is connected to the inverter. This is the negative side, and this is the positive side of the battery. And through the inverter circuit, it goes to the transformer, and we get the output. Here we have connected the primary side to the secondary and secondary to the primary to get AC output, so that we can get a higher voltage. So here I'll show you when we switch on. So when the solar panel power, means when we get the output power, sufficient output power, our load is on. You can see here, so load is on. Next, as I connect the battery, still the load is on. Suppose if when the solar power is not sufficient to drive the load, when it is off, still our load is running because of the battery. So I'll show you the charging current which comes to the battery. This simultaneously this battery is being charged at this time when we get sufficient power from the solar panel. Now let me show you the charging current. So here I'll show you the charging current. I have connected an emitter in series with the battery. You can see the charging current is 288.34. It is varying, so a milliampere. So this is the charging current. So when we get sufficient amount of solar power, the battery is charging as well as the load is running from the supply, that is the solar panel. So when the supply is off, then battery is. This is how a solar power inverter works. So we have successfully implemented this in our project, and we will further continue with this project to improve this output sine wave from the inverter circuit. So thank you for watching.